Hi, everybody. My name is Kelly Grove. I'm the GIS and Earth Sciences librarian here at Florida State, and we are doing the GIS for Success Vector Geoprocessing workshop today. In the chat, again, is a link to a document that is the instructions, a good guide for what we're going to go over today. When I start sharing my screen, I am going to turn off my camera. Guys don't want to stare at the side of my face while I look at my other screen. Please feel free to put any questions or anything into the chat or speak up if you need me to repeat anything or if I need to slow down if I am going too fast. Okay, I'm gonna get my screen shared. And let me just open up my chat off to the side. That way I can try and keep an eye on it if there's any questions. So today what we're going to be going over are some common geoprocessing tools. So these tools are really important because they allow us to take data that we find and kind of run not only our own analysis, but then convert it into ways that are going to be more useful to what we're trying to do today. So what I have shared in the chat with you all is this document where it has all of our lists of what we're going to be doing today. It has links to our data and where that data all came from. And we're going to go ahead and start working through. So the very first geoprocessing tool that we are going to be working on is buffers. So buffers, here, I'll even put this here, that way you can kind of read along with me a little bit. Buffers are basically a way that we can draw a zone around a point, a line, or a polygon, so that it encompasses an area within a specific distance of that feature. So, for example, this is really great in helping illustrate, flooding that can occur during heavy rains of a river, or perhaps trying to project a zone distance from, say, a gas station or school when people are planning on where to build. So what we're going to start with is we are going to add in our water. Let me just throw this in here. We are going to be working with, GIS workshops, sorry. We're going to be working with our geo vector processing data that I have already in here. So you just need to download all of these data files, as we will be using all of them. And particularly the first one we're going to use is our waterways of Florida. So go ahead and add that in simply using our vector geoprocessing, or vector, sorry, our vector layer input tool. I'm sorry, I am tripping over my words. And our geoprocessing, and I want waterways of Florida, making sure I put in that shapefile add. And then we're also going to add in the Florida shape simply to have another kind of zone of reference. So I actually keep that one in my QGIS workshop file. Florida, here we go. Okay, so as you can see, we have our waterways here. We have the shape of Florida, just that way we have it for reference. Let me reorder these, that way waterways are drawn on top. Excuse me while I kind of cough. And it's very simple. What we're going to start up here is coming to Vector, Geoprocessing Tools, and we're going to select Buffer. Now, Buffer is... what's great about QGIS is it does its best to clearly define what you're trying to do when you're using one of its predefined tools. So we have a great little explanation of it over here. Now, because our input layer they list these in the order of drawing. So we know we want to buffer waterways. We're not trying to buffer the state of Florida. It automatically sets a distance of 10. Now, I want you guys to notice something. We have a warning mark right here. What this means is, and if I hover over it, it's telling us that the waterways are drawn in degrees. And so what that means is it's our projection system that we are working with. So this is currently being drawn in the WGS 84, so the World Geodetic System, which is pretty standard for GPS. And this is a coordinate system. Now, a geographic coordinate system places data on a round surface. So its units are in degrees because it's trying to be projected in like a 3D almost way. So it's harder for us to calculate distance when it's in this type of format. So what we need to do is we need to work around this problem, because if I run a buffer while it is currently in this state, what we get are these giant dots, okay? So it drew it within 10 degrees of those lines. So we just get giant dots because it's 10 degrees upon 10 degrees upon 10 degrees. It's too large. It doesn't work. So what I'm going to do is I'm just going to remove that because that doesn't look pretty and we don't like it. And let me zoom back to our layer size. There we go. So what we need to do is we need to convert our waterways of Florida to a CRS, which is a coordinate system. So this is a way of converting our degrees into a unit of measure. Excuse me. So our geographic coordinate system defines where on the Earth the data is located, whereas our projected coordinate system, or our CRS, is tells us how to draw the data on a flat surface. So in our document, I do have a list of resources that can tell you more about this if you are interested in learning more. So don't be afraid to go and look at that. So what we can do, just to confirm that it is being drawn in a different, it is being drawn in a way that doesn't work for us, we can come down here and we can go to layer CRS. And what we can see is it right here, it's being drawn in the WGS 84. And what we can do is we can reset the CRS layer. So if you click Set CRS Layer, it opens up a coordinate reference system indicator. And so we can then search for a specific coordinate system that works for us. Now, I'm giving you this one just because it will be of help. So we're going to be looking for the NAD 83 Haran, Florida. Okay, so I happen to have used this one, so it popped very quickly for me. If you type in this coordinate system and it's not popping up for you right away, you can search EPSG 3087 right down here, and it will pop up with the same one. Okay, so I know I want this one, and I can click OK. Now this window is asking, hey, you're going to be converting this. Are you sure you want to convert it? And then it's also asking us, do you want to convert it to, it's just kind of double checking, converting it to the right way, and that it's going to be done in meters. We're going to click OK. Now it appears that our waterways have disappeared. Simply what is done is because it's been redrawn, it looks like it's moved. So if we again right click and zoom to layer, there it is. Okay, so it's drawn back to where we need it. So theoretically, what we can do is come up to our vector, our geoprocessing tool, and buffer, and now it has it in meters. Okay, we're not getting a warning sign anymore, and we could hit run. However, we are still getting those giant dots. Now, this is because there's some kind of background glitch. I'm not totally sure why. The program didn't fully reset our projection the way we wanted it. So what we're going to do is I found a workaround, kind of digging through a bunch of GIS forums, like looking at Stack Overflow, a QGIS Reddit, and I've linked to the thread where I found the workaround to reset the correct CRS so we don't have this problem. So what I'm going to do is I'm going to remove this layer again and click OK. And I am also going to remove the original Florida waterways layer. Just that way we don't get confused as we're working through this. So remove layer. And now I'm going to re-add that layer. So add it in completely fresh. QGIS workshops are geoprocessing and my waterways shapefile. Okay, so I've re-added it. We'll go ahead and we'll zoom back to that layer. Just that way we can see everything. And what we're going to do is right click on it and go back to where it says layer CRS and we're going to export, my apologies, export and save feature as. Okay, this window will open up asking us how we want to save it in the information. So go ahead and leave it as GeoPackage. We are going to give it a name, a file name, and make sure to save it, probably in the same folder where your other information is. So I'm going to put it in my geoprocessing folder that I have for this workshop. And we're going to give it a name, something like waterways, something to distinguish it from the original one that we have. So it's going to be waterways, Florida, GDL. So basically I am labeling it with our new projection system, what we want to have it in. And then we're going to set the CRS. So we click on kind of like the little globe wearing what looks like almost a hat. And hopefully it saved your recently used ones. If not, you just use the filter again to select it. Click OK. And then you're going to click OK again. Now you should have a new system. CRS. Okay, and we're going to double check. So if we come down to our layer CRS, our projection is listed as correct. Now what we're going to do is we're also going to change the projection system, of our entire project. So currently down here again, we have that little globe with a hat. If we click on that, and we're going to change it to the same projection system, just that way everything seems to match up nice. Click apply, okay. And it kind of changed it a little bit. It made it look a little cleaner, a little flatter. Now, what we can do is run our buffer again over this one. So again, we're going to vectors or geoprocessing buffer in 10 meters. Click run. Okay, now it says we have a buffer, but it just looks like lines. What you need to do in order, because we made that buffer just like 10 meters on either side of the line, is kind of zoom in. And there you go. Now we can see that this is in fact kind of a wide line polygon. To better see it, if you drag the waterways above the buffer line, you can see where the original water line was drawn. All right, so now we have a zoned buffer of 10 meters. Sometimes when you're doing a buffer, you may only want to buffer one side of the line. For example, like if you had a bunch of streets and you wanted to buffer just one side to kind of show where a sidewalk would be, you can do that. So what we do is we come up to processing, toolbox. I'm so sorry. I apologize for my constant kind of clearing of the throat. And then we click on buffer, or we type in buffer, we can search buffer. And right here, there's a single-sided buffer option. Go ahead and click on that. And it should open up this window. It's going to ask us what layer we want to buffer one side of. Choose the new layer, the Florida GDL Adlers that we chose. We are going to say, okay, what's the distance? Let's go ahead and just to make it a little more obvious how it's being done, let's go ahead and make that one a 5. And you can choose left or right. We'll just go ahead and keep it at left and run. Okay, it says it's done, so we can go ahead and exit. Now, what I'm going to do is I'm going to zoom in again. Let me zoom out so I can make sure I zoom in on a cluster of lines to make it very easy to find. There we go. So now we can see there's that 10-meter buffer here. We have our buffered line at 5, and then that buffer continues out past it. So we were able to do a one-sided buffer. Are there any questions? I want to take a half-second pause while I just double check. Okay, I'm not seeing any questions in the chat, so we'll go ahead and keep going. So something that you may or may not have noticed is in our layers area, there's a little icon right here. This is indicating that these layers are temporary. So that means these layers could go away if you don't save your work properly when you exit the program. And you wouldn't be able to generate this layer automatic, or you couldn't show this layer automatically when perhaps trying to put this information into a different project. So what we can do is we can save them. So first, let's change its name. So we're going to do the green, my first one, which is the left-sided buffer, and we're going to rename that layer, and we'll do waterways, GDL 5-meter buffer left. Okay. And then I can just kind of hit enter and it'll automatically change it. We can also do this if I right click and I go to properties and I click on click on source. I can change my layer name here. So this could be waterways GDL buffer, or sorry, I was going to make that 10-meter buffer. Apply. There we go. It changed it right there for us. So we've given them a new name. Now we're going to save our layers. So we can right click on our temporary layer, and in our list, there is a make permanent option right here. So if you save it, it's going to say, okay, what file name do you want to give it and where do you want to put it? So I'm going to put it into the same folder where we added our other new waterways, and we'll go ahead and give it a waterways GDL 5-meter buffer left, and save, and then click OK. Now our temporary icon is gone. So we're able to save it and we'll be able to use it again. And it's just a good habit, especially if this is something that you want to use later on. Now what we can go is we're going to move on to our next our next geoprocessing tool. And this particular tool that we're moving to is clipping. So I'll just move this over here so we can kind of read the definition together again. So clipping is really useful for reducing data sets to the pieces that you want. Okay, so sometimes we get these very large data sets that have they cover a big area, and we just kind of want to cut out a specific piece. So like using a cookie cutter to cut out a piece piece of dough, and we just want the piece that's within the dough. So the best way we can play with this one is if we add the geoprocessing, if we add the, I want the Tallahassee city limits, okay? So we add in the shapefile for the Tallahassee city limits, add, and then we also want the LU North. So this basically this is standing for like the Northwest Florida Water Management District. Okay, that's what the NWFWMD stands for. And go ahead and add that and close. I am going to turn off all of our, our waterways layers, and zoom to our Northwest Florida layer. Okay, here we go. So as you can see right here, the Northwest Florida water management layer is all of this orange. The city of Tallahassee, let me move it up above, is that purple layer, okay? We only want the area of the Northwest Water Management District. We only want the area that covers Tallahassee. That's what we're attempting to do. So again, we come up to our vector and our geoprocessing tool and we go to clip. Okay, our input layer, this is the our input layer is the layer that we want to clip. Our overlay layer is the layer that we want to, is like our cutter, you know, what we're trying to define. So we're going to use city limits, okay? And then we go ahead and we click run. Now, you should have gotten a warning that there are some invalid features, okay? So basically that means that there are some geometries that were incorrectly defined in the Northwest Florida Water Management layer. What this essentially means is when we take data from other people, we can't always guarantee that everything is 100% correct and that we may have some problems with it. So I want to show you a way of how we can fix an invalid geometry. So go ahead and close out of that. And again, we're going to go up to our processing toolbox. And this time in our search, we're going to search check, because we're going to check validity. Okay. So double click. There we go. I wasn't double clicking when I should have. And we make sure we have the correct layer in here. Go ahead and leave the method to geos. So basically what's going to happen is when this is done checking, it's going to generate 3 new layers: a valid output, a invalid output, and an error output. Okay. So what works, what doesn't, and what errors we essentially get. So we can go ahead and we can click run. So we're checking the validity of those elements of the layer, and I'm going to take a sip of water while this runs. Hopefully that helps my throat. And it may take a minute. Okay, and I can go ahead and close that. So I am just going to turn this off for a minute and valid output. Okay, so all of the errors are purple dots. The invalid outputs are in the pink, and everything that is valid is kind of this yellowy orange color. So that gives us an idea of where the errors are, where the mistakes are in this data. Now we're just doing a kind of a quick fix. So in our geoprocessing toolbox, what we can do is we can search fix, and there is a fix geometry option right here. So go ahead and double click our fixed geometry. We want to put in our input layer, the water management district layer, and run. Now, what this is going to do is essentially, it is checking all of the geometries and making its best estimates based off of all of that data to kind of fix it and make it so everything is valid, essentially. So this is a very kind of generic way of fixing these elements. So we can go ahead and close. I'm going to turn off the invalid things. And so our fixed geometries is now in this pink layer. And just kind of gives us an idea again of what's going on. So let's go ahead and finish clipping our clipping this particular area. So we want the fixed geometry, and then we want to clip it to the city of Tallahassee and run. All right, it finished running. Now I have a clipped area. So if I turn off fixed geometries and the city limits, I can now see where it is. So I'll turn on fixed. It's just all of this the black lines are making it difficult. So now that green area is our clipped geometry, and it does match the original fixed geometry. See how that works? And it just happened to be city limits is drawn on top. So if I put it above there, it doesn't matter. So now we can kind of see how that's going. And then that's in the state of Florida. We can see what's happening. So now we have a correctly clipped layer that we can play with. So not only did it clip visually, but if I right click and I go to open attribute table, it also clipped all of the attributes. So to include just what we want in this layer. So here, just keep in mind, 4,983. If I look at the attribute layer of our original Northwest Florida Management District layer, oops, went too high. Did I not click on it? Or is it taking a minute to think? Open attribute table. I think QGIS is taking a minute to think. Either way, what you will see is, oh, it popped up for a second. Where is it? There it is. Okay, so there's over 36,000 you see in this table. So we were able to also limit down the number of attributes based off the city limits that we had for Tallahassee. And it just had opened that table twice and was taking it a minute. So that is clipping. Okay. Are there any questions before we move or before we do our next one? Because we are going to clip a raster this time. So this is slightly different than clipping a vector, just because our data will look different, but the process is very similar. And I just kind of wanted to share that with you guys to see how that looked. So what we're going to do is we're going to go in, and this time instead of vector, we're going to go to raster. And we are going to add in our, it's the Tallahassee area raster. And we can add that in. It is going to ask us, it's letting us know what's going on. Just go ahead and click OK. It's fine. Add, close. Oh, I added it twice on accident, but it doesn't matter. And we'll go ahead and zoom into that layer. Where's my zoom? Zoom to layer. There we go. And I'm going to just turn off clip for a minute. So this is what a raster looks like. This is just kind of showing elevations, I believe is what I chose here. And we're going to go ahead and clip this. So if we click on raster, and we want raster extraction, clip raster by masked layer. Okay, so this masked layer is essentially we're saying, hey, we have a vector area that we want to clip it to. So our raster is in our input layer. Our masked layer is going to be the city of Tallahassee, city limits of Tallahassee. There it is. and clip it to that area so we can run it. Close. Okay. Right now it doesn't look like it's there, but as soon as we turn off this raster, oh, I forgot I accidentally had two raster layers in here. So let me remove that other raster layer. And then there is now our city limits raster, and it does match. So as I turn them on and off, you can see that that raster now matches the city limits. I just thought I would include that, just that way we get a moment to play with a vector geo or a raster in our vector geoprocessing. So now we're going to do is we are going to take a look at the convex hull. Okay, so as you can see in this image, this was really the best way I could think of how to describe it, is a convex hull is a way of kind of generalizing a shape. So, you know, when we need more simplified maps, that's essentially what this is trying to do. So what we're going to do is I'm going to turn that off, and we want our city of Tallahassee, and we're already zoomed in, and we're going to just make a generalized shape for the city of Tallahassee. So again, we come up to vector, our geoprocessing, convex hull, make sure it's set to the city of Tallahassee, and run. So close. So our convex hull is in the yellow. Our city of Tallahassee is again in that purple. So as I turn it on and off, that is the generalized shape that it created for the city of Tallahassee. That way it made sure it encompassed all of the most outer points without having to go in and out all of the way. That's just something nice, easy, quick way of doing it. Now what we're going to do is we are going to look at the geoprocessing tool of difference. So this is a way of determining what areas fall within one area but not another. Okay, so kind of like the Venn diagram, you know, how you have that middle area where everything is common, where this is a way of helping us find the things that fall in the outside areas between two sets. So we're going to zoom to our Florida layer. So that way we can see the whole state. And I want to have my city limits polygon positioned. I'm going to put that at the very top. And we're going to turn off all of our other layers. Okay. So we can see that purple dot of the city with Florida underneath it. We'll go to vector, geoprocessing, and we're going to go to difference. For our input layer, we are going to set it to the state of Florida. And again, our overlay layer is going to be Tallahassee. And run. Okay. So we now have a new state of Florida. And if I turn off the city limits and turn off the state of Florida, now there's like a little hole where the city of Tallahassee is. Okay. So perhaps you want to use this, you know, removing elements that are no longer there. Okay. So so an entire city wouldn't necessarily disappear, but say you had data where there was a forest, you mapped a forest and there was a grouping of trees, and that grouping of trees is no longer there. This is a way of removing them, type of thing. So that is essentially what happens there. Now we're going to play with the tool dissolve. I made that really big. So this is a way of combining features into a new feature based on the attributes of the same class. I know that sounds weird, but it'll kind of make sense in a minute. So we are going to zoom to our clipped vector that we made. Let me turn it on and zoom to that layer. Okay. And what we're going to do is we are going to open up the properties and we're going to go to symbology, and we're going to do a categorize symbology and click classify. Oh, that's because I forgot to set what our value is. My apologies. We're going to set the value to level 1 and then classify. Okay, so essentially what that level is, what the level of this data is telling us is what the land use is for each of our categories. Okay, is it agriculture? Is it barren land? Is it water, wetlands, so on? And we can click apply. Okay, now we have this very colorful element. I'm going to turn off the brown because there's a lot of brown here. This very colorful map. Excuse me, I hiccuped. Map of Tallahassee based off of the first level use of their land. So what we're going to do is we're going to dissolve areas. So like, see how we have all of these lines that kind of separate things? We're going to dissolve areas so that way the same ones look like one, almost like one big polygon. So if we come up to our geoprocessing tools, oh, sorry, vector, geoprocessing, and we're going to go to our dissolve. Okay, we want it to be the clipped layer because that's what we were doing. And then our we're going to click on our 3-dot button here. And this is where we define what attribute we want them to be dissolved in. So we're going to do level 1 because that's why we did our categorization, so we could kind of see what it looked like before then. And click run. Okay, I can close that. So it created this dissolved layer. Oh, this dissolved layer. I don't know why we got that big thing. So we can go ahead and open up the attribute table. And now we have our, we only have 8. There we go, level 1. I was looking, for some reason I was looking over here when I should be looking right here. Our level 1, it's showing us only those 8 types of land uses that we were showing here. And if you notice, we have a lot less of those little dots. So let me close, or we have a lot less smaller polygon lines drawn within. So if I turn off our dissolve, you can see, for example, you can really see it down here where there's these kind of circles. And when I turn dissolve back on, those circles kind of disappeared. So now they're all in this same area. So if I come back to our attribute table of dissolved, and let's go ahead and highlight, oh no, highlight any of them. Now all of those yellows are those indicators, and I chose rangeland. I picked one at random, chose rangeland, and it highlighted it there. So that's essentially what dissolve did, is we then made it a little bit easier to quickly group all of the land uses based off of what was going on. And we could even then do our properties and our categorize level 1, classify, apply. And there we go. It's lots of colors again, simplified kind of shapes with less polygons within it. Now what we're going to do is we are going to do an intersection. So this is used to help determine what layers overlap other layers. So we're going to add in another vector layer, and this time we want building footprints. I know I have you guys adding a lot of things, and the reason we didn't do it all at one time, you see, is our layer area is getting pretty big as we're playing with everything. Okay, close. Let me just kind of shorten that up. That way we can see all of our raster layers right here. So we have our building footprints. We're going to turn off, make sure all of your other layers are turned off except for building footprints, and turn on the Tallahassee city limits. Make sure building footprints are, maybe over the city limits so we can see where those fall within the city limits. And we're going to go back to our vector or geoprocessing, and we'll do our intersection. Okay. Here we want to have building footprints set as our input layer. We're going to have our overlay layer be the city limits and run. Okay, I can close that. So we now have this new layer. Where'd that go? Did it not actually run? Because we should have a layer called intersection. Let me rerun that. I don't think it ran, or I closed. Maybe I didn't actually click it. Intersection, building footprints, city limits, run. Yeah, I think I closed out of it too quickly, and so now it's taking a moment, and it's going to run to create that layer. So if we can give it a minute, I think, we've just been running a lot, and so my computer is just like, oh, I need a minute. Take a second to kind of breathe. So this will create a layer called intersections once it's finally done. And if it doesn't wrap up here in a second, then I can kind of show you something slightly different. But it should hopefully finish relatively quickly, I hope. And mostly because I need to wait for it to run, because I can't really run any of our other programs very well if it's trying to run this in the background as well. So this is something to keep in mind when you are doing a lot of a geoprocessing, is the more you run, your computer's going to stop. It's going to get maybe a little hot. It's going to need a minute to do all of this. So it is doing all of our intersections. It is just taking a moment. I am going to take another drink of water. It is thinking. It's just taking its time. I'll kind of just show you here. I have a GIF of it happening right now. So when the intersection, I know it's happening very quick. The intersection, we turn off the other building footprints. All of those brown areas are now just the building footprints that are within the city limits of Tallahassee. So I happened to zoom in on the stadium, for example, and I believe that was just pure luck when I was capturing that particular GIF for the demonstration purposes. But as you can see, kind of once you get a hold of how one processing feature works, it becomes fairly easy to understand how the rest of them work. It's simply a matter of figuring out which geoprocessing tool is going to help you best answer your question. So are you trying to limit data to a specific area? Are you trying to find where areas overlap, or where areas might be different, where they're not overlapping? That kind of thing. So we're waiting. I'm hoping this wraps up soon, because I have, let's see, we're in our intersection. I have 3 other processing tools I would like to quickly go over. However, I will let you know that the instructions pretty much spell it out. It is pretty simple in case we run out of time. I'm hoping we don't. It's simply just a matter of the waiting game at the moment, and I apologize for that. Are there any questions or anything? Well, I will say what I am going to do is while while we are waiting for this to finish wrapping up, I am going to post a link into the chat. This is a link to a survey for this workshop. I please ask you to participate in it. Not only will your name get entered in to win some free swag, like we have bucket hats and like fanny packs, like water bottles. We have a bunch of different things. But it also lets me know what kind of workshops you would like to have in the future. It lets me know what you were hoping to learn, what you did learn, or what you did not learn. Um, in this workshop. So please take that survey. This video will be sent out to everyone who did register. So you will have access to this later in case you want to view this again. We're almost there. We're at 82%, almost done with this particular processing. Hopefully my other ones will not take this long. I apologize for that. But this is the joy of a live demonstration. You get to see troubles that I face when sometimes I even forget to click the right, where I sometimes click the wrong thing or accidentally put the wrong layer in the wrong spot. Almost there. Almost there. Yay. Okay. Intersection. Yes, there we go. There's our intersection. I feel very silly because it looked like it ran maybe two intersections at the same time, and that's why it was taking so long. So if I turn off building footprints and I move our intersection up to the top, now we just see building footprints that are within the city limits. So if I'm on, it looks like we have them all. Turn building footprints off, it's just that area. Now what we're going to do is we are going to do a symmetrical difference. So this is used to create layers where only features from one layer are drawn because they are outside of another layer. So like the building, for example, what we'll do is we'll do building footprints that aren't in Tallahassee. So let me turn off intersection, turn on building footprints. We can come to our vector and we want our symmetrical differences. Set our building footprints to our input layer, and our overlay layer will be the city of Tallahassee, and run. This one is going to take some time as well. So essentially what this one will do was it will actually create holes in the city of Tallahassee, indicating that those features are no longer being drawn, but it will draw the elements that are outside of the city of Tallahassee. I'm going to go ahead and close this just for the sake of time. Even though it didn't finish completing, because I want to at least show you, make sure we have these other ones. So for we're going to do a union. So this lets us merge two layers without removing boundary lines that could potentially separate them. So this time what we're going to do is we are going to add in the layers of county commission districts. And then we're also going to add in election precincts for Leon County. Okay, and let me kind of zoom out. All right, so here is Leon County. Let me turn off building footprints in the city of Tallahassee. So There we go. Okay. So I have our election precincts is in the purple. When it's in green, we have the county commission district. So what we're trying to do is draw all of these political boundaries without really removing any necessary things. So we'll go to our vector, our processing, and we are doing a union. Go ahead and make our input layer the election precincts. And then our overlay layer will be the county commission. Excuse me, and run. That one ran very quickly because we have a lot less data in that one. So we have a union layer. We'll go ahead. I want to open up the attribute table and show you. So, let me open up precincts and show you that attribute table really quick. Okay, so we have some information in here. Okay, all that's going on, what's happening. And then if I open up our union tab, or our union one, we now have some additional information. We have a district added here and a new shape. Okay, so it's saying like, hey, what was the additional shape now associated with this particular feature? But as you can see now, all of the election precincts are being drawn within the county commissions. And our very last one that we're going to do is we're going to do an eliminated polygon, or eliminate selected polygons. So this will help us merge layers together by erasing a common boundary. So as we know, election precincts and things like that have a tendency to move based off population. So this would be one way of doing that. So we're going to set our election precinct layer to be the most visible one going on. And we are going to merge a boundary. So we can use our select tool right up here and select a few random precincts, preferably ones that are kind of near each other. Come on, why don't you let me click? Select by polygon? Are you gonna let me? Nope. Sorry, it's being... Why are you being difficult? Okay, that was interesting. I didn't want that. Okay, I'm going to go into the attribute table and choose them that way. For some reason, it's being slightly annoying. So, okay, so shift and oh, not 3. We'll just do 1 and 2 right there because you can see that they are together now. And then we're going to come up to our vector processing tools, eliminate selected polygons. We have it set to our appropriate layer. And then where it says merge selected polygons with neighbor polygon, we are going to use our drop-down menu, and I want to do largest common boundary. Okay. And run. So what that did is, let me turn that on, is see, it removed the largest common boundary that was going on. So now it's all in there together. So that's a way that you can join things